Hey guys, and welcome to another one of my tutorials. In this tutorial, I'll be showing you how to set up a jet in your game, just like this one. And as you can see, it has the flaps set up, so when you pitch, the flaps move, and also with yawing and with rolling as well. So as you move the plane around using the mouse and keyboard, the flaps will move in the correct way. And also you can see as I speed up and slow down, so I'm going to go ahead and slow down real quick, you'll see the thrusters in the back actually go down as well, and I start to slowly fall out of the sky. And then when I speed back up again, you'll see the thrusters come back, the camera kind of zooms out. So it has a few nice little effects like that as well. And one thing I just want to say up front is this is not some sort of military grade physics simulated jet. The math behind it is pretty gamey, I guess you would say. It's not like it's using exact physics to figure out how to make it fly. It's more of, how Battlefield or GTA would do their type of jets. So it's not like exact physics, but it's definitely good enough for a game, and you may want to tweak it a little bit for your purposes, depending on the type of game you're making. But it should definitely give you a really good starting point for any type of jet or similar type of aircraft you want to make. So with that being said, let's go ahead and jump right into it. So I'm just going to stop this and then move this project over here. And you can see I have another project, and this project is actually totally empty. A totally brand new project. I just used a blank template, and then all I did was I imported this map. So you can see if I press play, it just gives me the default camera. So there's no jet, there's nothing in here yet. I don't want you to think I'm starting this tutorial from, already halfway done. There's literally nothing in this project other than this map, just so I have something to fly around with. So with that being said, the first thing we're going to do is we're going to import the assets. So in the description of this video, there will be a link to a download, and the download folder should look something like this. So you should have some sort of folder that has a bunch of FBX files in it for all the different parts of the plane, and then a textures folder as well for the different textures. So the first thing we're going to want to do is import these. So let's come back here and create a new folder inside of the content directory, and we'll just call it assets. And then inside of here, let's grab all of our FBX files and drag them in. And you can just leave all this as default, say import all. And you can see we get a bunch of different FBX files for different parts of the plane and some materials. And the reason that the plane is all kind of chopped up like this is because all of these models right here, and these as well, are for the different flaps. And so they need to be separate models because we want to rotate them independently of the plane itself. So having them as separate models, we can attach them to the plane and then rotate them and pitch them as we need. And then we also want one for textures, so I'm just going to right click, make a new folder for textures. And then back over here, let's go inside the textures folder, grab all of these guys and drag them into the texture folder. And give it a second. All right. So now we have all our textures. And you might be thinking that this is a lot of textures, and it is, but if you look at it, this F15A, B, C, D, E, F, G, and H, so all of these are simply just different versions of the aircraft, like different colors, different paint jobs. So really you're only going to be using one of these and then all of these other four. So it's not as crazy as it looks. All right, so we need to kind of set up our plane real quick to have the correct materials applied, because if you look at the plane right now, it's just this kind of giant white mesh. So let's go back and set up our materials first. So over here, we have the F6 or the F15 material. Let's go ahead and open that up. And so inside of here, we're going to be using the textures and hooking them up to the correct values. So let me delete this guy, and let me go reference my other project real quick so I don't mess this up. Okay, so the first thing we're going to want to do is, if you right click and search for texture, sample, I think it's called. Yeah, texture sample. We want to bring in a texture sample, and the texture we want to sample is, if you search this, or if you hit this drop down and search for F-15, you'll see, or maybe it's, what is it called? F_15. You'll see we have A, B, C, D, E, F, G, and so on. And you can just click on any of these that you want. I think in the other project I used D, which is kind of like this woodland camo. But again, you can use any of those for the base color. So go ahead and hook that up to the base color. And then the next one we want is the specular map. So you can actually just copy and paste this. And over here, search for specular. We want this F15 specular. And we'll go ahead and hook that into the specular color. And then we also have one for metallic, I believe, actually. So move that down and copy one up here. And search for metal, I think it's called. Yeah, F15C metal. And that goes into the metallic one. And then we have two more, one for the normal map and one for the ambient occlusion. So again, just copy and paste. The normal one, search for normal. F15C normal is the one we want. And hook that up. And the last one we want is this ambient occlusion. And if you search for F-15, we want the CAO, which stands for, AO stands for ambient occlusion. So we're going to hook that up like so. And now we can hit apply and save. And if we come back here to our fuselage model, you can see it has this texture on it, but it doesn't have any of the flaps or anything like that. And that's because all of these are going to be attached inside of the code. But you can see there's sockets for them so that we know where to attach them at. But we will be doing that in a second. The last thing we need to do for the materials is hook up this glass material. So if we come back here to the content directory, we have this glass texture, or glass material rather. So if we open this guy up, we can just go ahead and, actually, let's keep this, except just change it to like a blackish color. So if you double click on it, it will pop up this window, and just change it to, let's just make it black. Just do 0, 0, 0, and alpha of 1, and go ahead and press OK. And then if you click on this glass node over here on the right, we want to change a couple properties of it so that we can make it transparent. So in this dropdown next to blend mode, we want to select translucent. And then down here under, what's it called? Lighting model, yeah. Lighting model, we want to change this to surface translucency volume. And what this will allow us to do is give it an opacity while also giving it a specular color. So for the specular color, if you hold down 1 on the keyboard and left click, it'll create a little constant variable for you, and we want to hook that up to specular. We want to give it a nice 1 since glass is nice and shiny. And we also can copy and paste that and give the roughness 0 since glass is not very rough. And then finally, we want to set the opacity of it. So copy and paste this again. And we'll set the opacity to something like 0.4. You can do more or less depending on how opaque you want it. And then if we hit apply, it should update here in a second. It might take a second because it's kind of transparent. Sometimes that takes a second. All right, there we go. So now we have our glass material, and save. So if we come back here to our model, oh, right. So the glass model isn't actually part of this model, but once we build it out in code, you'll see the glass show up. Okay, so we have all of our materials set up now. So you should have both of these kind of looking like how they should look. And then now that we have our materials, we can go ahead and set up the jet itself. So if we come back here to the content directory, we can right click, and we want to make a new blueprint class. So select blueprint class, and we want it to be of type pawn. So select pawn, and we'll call it BP underscore jet, like so. And then if we double click to open this up, we can edit it. So this blueprint is going to represent our jet. So there's a bunch of components that we want to add to this over here on the left. The first one is going to be a static mesh for the fuselage, which is the body of the plane. So we'll go add component, search for static mesh, and it will drop in a static mesh right here. And actually we want to go ahead and just replace the default scene root because we don't really need a default scene root. So just drag it on top and it will replace it. And we can, actually let's rename this just so it's a little easier. Just call it fuselage, just so we know what it is. And then in the static mesh, search for fuselage. I think I'm saying that right. Hopefully I am. I'm not much of a plane guy, to be honest, but all right, so we hook that up, and the next thing we need is the glass. So we'll say add static mesh again, if I can type. And then we want this one to be a child of the fuselage, just like it is right here. So make sure that it's a child, like I have it. And then over here on the left, search for glass. And you can see it should pop up right where it's supposed to be because its origin is using like the same origin as the plane. So it should pop up right on top of it like so. So now that we have those two, the next thing we're going to want to hook up is the camera because we want the camera to kind of be back behind the plane. So select the fuselage up here and then go ahead and hit add component. And we're going to add a spring arm, and this will kind of give us a nice little lag effect to the camera. So go ahead and add that. And then click on the spring arm and add a camera because we want to add the camera to the spring arm. And let's make some properties real quick here for the spring arm. So click on the spring arm because we want to change a few things because right now it's like inside of the plane. So we want to set the target arm length to 800, and you can play with these values to make it, closer or further away depending on how you want it to be. But these are just the ones that I used for my demo project. So, and then the socket offset, we want to set it to 300, so it's a little bit above the plane as well. And then something that's going to make it really nice is if you come down here, and I can't find it, yeah, lag right here. So we want to enable camera lag. And again, this will make it so that the plane appears to be moving and then the camera kind of follows it. So we want to select this. It'll make it look a little bit nicer. And we also want to select enable camera rotation lag, which kind of does the same thing. And then you can tweak these values as well. Basically, the lower the value, the more lag there is. I found that 10 and 5 work pretty good for this. And I believe that's all we need to do for the spring arm. So let's make sure we save all this. And then the next thing is the camera. Actually, there's nothing we need to change on the camera. All right, so, I just remembered one thing I probably should have mentioned at the beginning. Actually, it's not a big deal, but I'm on version 4.25, and I'm using that version specifically because it's the newest version of Niagara, and I'm using Niagara for the particle effects. So if you do care about the particle effects that I'm going to be creating at the end, like you want to be able to copy those as well, I would highly recommend updating to 4.25 or newer, so that you'll have the Niagara plugin. If you don't have it, you can just come up here to the top and go to plugins. It's under edit plugins. And if you search for Niagara, just make sure it's enabled. It's going to look a little bit different, like the plugin, if you're on an older version of Unreal, which is why I highly recommend that you upgrade to 4.25 or newer so that it looks the same as mine. But yeah, I probably should have said at the beginning, but I just forgot. So sorry for that random aside, but 4.25. Okay, so now we have the body of the plane set up, and we have the spring arm and the camera. The next thing we want to do is we want to add all the flaps and the rudders and the elevators and all that stuff to the plane. So to do that, we're going to be using the sockets that are on the plane. Because if you go back and you look at the plane, you can see it has sockets already on the model for where these flaps and rudders are supposed to go. So if we come back here, all we need to do is make sure you have the fuselage selected and hit add component. We want to add another static mesh. And we're going to be adding, I think, 8 of these total. The first ones, I believe you call them ailerons. I'm not 100% sure, but it's spelled IELERON, and then I'm going to put L for left. So this is the left one. And then the static mesh, just simply search for that same thing, aileron L. And you can see by default it pops up in the middle of the plane, but all we have to do to attach it to the socket that it should be attached to is come up here and search for, under parent socket, search for the aileron L. And you can see just like that, it pops into the correct spot. And even nicer than that, if we rotate it, which we're going to be doing, you can see it rotates correctly for us, as long as we're rotating it along this y-axis. So it's really nice to have a model configured the correct way when you're doing something like this, because it makes it 100 times easier. But yeah, we're basically going to be rotating this in code later. So for now, just leave the rotation as, leave the rotation as 0, 0, 0, like so. Make sure it's set to 0, 0, 0. And then we need to do that for all the other pieces. So we can just duplicate this and call it R, and then make sure you change this to R and change this to R. So those are the 2 ailerons. Again, hopefully I'm saying that right. And we'll just duplicate this again. The next ones are the elevators. So elevator L. And again, it's just the same process. We search for the elevator L and attach it to the elevator L socket. And duplicate this and do it for R. Search for R. and attach it to the socket. And then the next ones are the rudders. So duplicate this again, call it rudder L, and select, where is it? Rudder L, and attach it to the rudder L slot, like so. And so these are these back here. Again, duplicate, rudder R, attach it to rudder R, and rudder R. And then the last one are the flaps, which are going to go right here in these empty spots. So duplicate this again, call it flap L, and we want to find the flap L, attach it to flap L, and finally the last one is the right flap. Let's go ahead and, go ahead and attach that one as well. Okay. Now you can see we have the jet fully complete. It has all of the flaps and the rudders and all that good stuff, and it also has this nice glass on it. Alrighty, so now that we have that all set up, we want to go and we want to tell Unreal that we want this model to be the model that we use when we start up the project. So I'm just going to save real quick, and then back inside of here, if we go to the world settings, which don't appear to exist, where is that? Windows, world settings. Usually this is over here by default, but apparently it wasn't for me. All right, so under the selected game mode, no, game mode overrides. Maybe that's not where we do it. I think in the project settings you can do it. If you go to maps and modes, select a game mode. We might need to create a new game mode if it's not going to let us do this. Yes, we are going to need to do that. Okay, so real quick, let's just right click and create a new... Actually, we might not be able to do that. Hold on. We might just be able to drag this guy into the world. And in the details panel, select auto possess. No, auto possess player, player 0. Let's see what happens if we run this. Hey, okay. That actually worked. So you can see it's auto possessing our jet. Obviously, our jet doesn't do anything yet. It just kind of chills there. But that is totally fine for right now. Okay. So let's go ahead and save this. So now we have our jet in the world. Next thing we need to do is get this thing actually flying. And for some reason, it's taking forever to save. Just give it a second. Come on. Okay, so back in the VP Jet, let's go to the event graph. So let me think about the best way to do this. So I think probably the best way to do this is to create all the variables and functions that we're going to be ending up using first, and then we'll kind of go in and fill them out later, because I think that will kind of help it make a little bit more sense, and it'll be a little bit easier to follow. So let's go ahead and create the variables that we're going to be using first. So they're pretty much all going to be floats. So come over here on the left where the variable button is, and go ahead and press it. And the first one we want to create is the max thrust speed. And make sure you change this to a float. And this is what I call a constant variable, because this is simply a variable you're going to set at the beginning of the program, and we're never going to change it again. So we want to set it to private, and we also want to set it to blueprint read-only, so we can't change it. And then I'm going to add it to a specific category. I'm going to add it to the constants category, and then, actually that's probably good, just constants. So you can see down here we have a constant variable for max thrust speed, and I like to kind of separate my variables into constants and non-constants, so it's easy to tell at a glance which variables I'm changing in code and which ones are more just, values that are supposed to be set at the beginning and then they never change. So we're going to have a few more of these constant values. So this one's for the max thrust speed, which is of course, the maximum speed that the plane can go. And then we want another one, so duplicate this and just call it min thrust to not fall. And I know this name's a little bit confusing, but it's basically just the minimum thrust that's required for the plane not to start falling out of the sky because it's going too slow. And then we want another one for the thrust I can't spell multiplier. Thrust multiplier. So this one's going to be used for determining how fast we can accelerate our thrust and how fast it will decelerate. And then we want another one for gravity. So gravity. It's just going to be a constant variable for gravity. And we want one more for drag, which is kind of like the air resistance. So if we go ahead and compile, we should get default values for all of these. So let's just go ahead and set these right now. So the drag is going to be 0.25. And again, once this is all coded and working, feel free to come back and change these constant variables to, slightly tweak it to make it feel better for your game. But for now, I'd probably just recommend setting the values to what I'm setting them to so it at least matches my tutorial. So drag's going to be 0.25. Gravity is 981, which is actually, that is the value of gravity, because in Unreal, one Unreal unit is like 1 centimeter, so gravity is like 9.81 meters per second squared, so this is actually a real number. I'm not just making it up. And then the thrust multiplier, we're going to set to 2500. The min thrust to not fall, which is, again, how fast, like the minimum speed you need to be moving to not start falling out of the sky, even if it's slowly, is 4,000. And then the max thrust speed, we're going to say, is 10,000. So this is the fastest that you can go. And then there's going to be a few other constant variables we want to add, but we want to add them to a different section. So to do that, let's just go ahead and right-click and duplicate this drag one real quick. And we will call it the max flap pitch. And before we do anything else, let's come back here to the categories. And if you hold down Shift and press the backspace, it will create like a little vertical bar. And that's how you make subsections for categories. So we want to add a subsection for control surfaces. And the control surfaces is, I guess it's just an airplane term for the different types of flaps and rudders. Apparently those are called control surfaces, according to Google. So these constants inside of this section have to do specifically with the flaps and the rudders and the elevators and ailerons. So we're going to want a max and a min pitch, or yaw in some cases, for all of these different values. Or actually, we only want a max, because the min's going to be the negative version of the max. So the max flap pitch, we're going to set to 10 degrees. Actually, let's create them first, and then we'll set them. So just duplicate this one, and we'll make one for the max elevator pitch. Max elevator pitch. And again, duplicate that one for max rudder. And this one's actually going to be yaw, because the rudder is actually yaw from left to right, as opposed to pitching, because they're in the back. And then finally, we want the max I can never remember this word, aileron pitch. Okay, so now if we compile this, we can go ahead and set all these values. And again, you can change these to whatever you want them to be, but I kind of just recommend following the tutorial for now. So this is saying, like, how much can these pitch? What's the maximum value that these flaps can pitch? So I'm going to say 10 for this one. The elevators, which are the ones in the very back, I'm going to set to 25 to make it a little bit more noticeable. The rudder yaw, I have this set to 45, and this is in degrees. And the ailerons I have set to 45 as well. All right, so now we have all of our constant variables set. So these are all the variables that are not going to change in code. We're just going to be reading from these variables once we start writing the code. And let me just save this again. I don't know why this takes so long to save, but apparently it does. So the next section we're going to be creating is going to be called dynamic variables. So let's just duplicate this drag one again to create the next variable. So this one's going to be called the thrust speed. And again, before we do anything else, let's move it to the correct category. So I'm going to move it to a dynamic variables category. And since it's a dynamic variable, we want to uncheck the blueprint read only, because obviously it's not going to be read only if it's dynamic and it's changing. And for all of these, make sure you select this one, the dynamic variable down here, the one we just created, and make sure you set the default value to 0, because all these dynamic variables we want defaulted to 0. So the thrust speed is basically obviously just the current thrust speed of the plane. And then the next one is going to be current speed. Now the difference between the current speed and the thrust speed is the speed that the thrusters are trying to propel the plane at. But the current speed is the actual speed that the plane is being propelled at. Because if you think about it, if you just cut the engines on a jet, it's not like the jet's going to instantly go to 0 miles an hour. It's going to slowly slow down over time. So the thrust speed when you cut the engine is going to go down to 0, but the current speed is not just going to immediately go down to 0. It's going to slowly go down to 0 over time. So that's why we need two different variables here. And then the final one we want is called applied gravity. And I'll explain this one a little bit later once we start working on it. But basically, to kind of simulate lift, we're going to have an applied gravity that gets applied. So if the plane's flying super fast, we're actually not going to apply any gravity to it because it's flying so fast that the air under it would be lifting the plane up. But if it's flying really slow, then we'll be applying some amount of gravity to it. So this value is basically going to be somewhere between 0 and our gravity value up here. And then the final variables we're going to want to create are for rotation. So let's just right click on the applied gravity and duplicate it. And we'll call this the target yaw. And again, before we do anything else, let's put it in the correct section. I'm going to put these inside of a rotation subcategory. So I'm going to put a little bar and say rotation. And you can see it adds it to the rotation category. So inside of here, we're going to have 6 variables. One for yaw, pitch, and roll, like the target yaw, pitch, roll, and then 3 more for the current yaw, pitch, and roll. So we'll have 6 in total. And we want to have a current value and a target value for each one of the different rotation directions. Because again, when you start rotating a plane, like when you start turning in a plane, if you turn the, if you turn the mouse or if you press the key to the left, the plane shouldn't instantly snap to the left. It should slowly turn over time to the target rotation that you want it to get at. And that gives it that nice, smooth, natural look. So that's why we're going to have a target and a current. And again, once we start using these variables, it will make more sense. But I just want to create them up front so it's a little bit easier once we get going. So target yaw, and then we'll duplicate this, and we'll have current yaw. And then we're just going to do the exact same thing for pitch and roll. So duplicate, and we'll say target pitch. Duplicate that one. Current pitch. Duplicate this one. Target roll. And finally, target pitch. That didn't work. Or sorry, current roll. Let me make sure I did this right. Target yaw, current roll, target pitch, current pitch, target roll, current roll. Okay, good. Okay, so I know that took a while, but those are all the variables we're going to be using. And hopefully it kind of made a little bit more sense that I explained them up front so that when we go to actually use them, it'll be a little bit easier to understand. All right, so the very last thing we're going to do before we start actually coding is define a few functions, kind of like we did for these variables. And then again, we'll fill out those functions last, kind of as we go along. So over here under functions, we're going to create 6 different functions. So the first one is going to be called update position, which, as you can probably guess, we're going to be using this function to update the position of the jet. So for the inputs, let's change this to a float, and we'll call this delta seconds. So the update position is going to be taken in the delta seconds, obviously, so that we can update its position based on the delta time. And we want to change this to access specifier private, and I'm just going to go ahead and move it to a private category as well, just so it's really obvious that it's private. And then we want one for updating the yaw. So duplicate update yaw. And this one needs to take in delta seconds as well, so that's fine. We can leave that like that. But we also want it to take in the yaw. So say yaw. And then duplicate this one, and we'll say update pitch. Pitch. And instead of taking in the yaw, we'll take in the pitch. And then, as you probably guessed, we're going to have one for updating the roll. Update roll. And we want it to take in the roll. And then we want one for updating. Actually, we'll leave that out. I was going to say updating the particle effects for the thruster, but I'm going to actually save that part to the very end and probably make it in a separate video, just because I think some people might not care about how to do the particle effects, or might want to do their own, or they already have their own. So I'm going to save that part for the very end, just in case people don't care about it. So we'll kind of skip that for now. And then I did have one more function called, oops, don't do that. Duplicate the update roll and call it print variables. And this function is solely just going to be for debugging to kind of help us see what's going on. And this one doesn't need to take in anything, so we can delete that stuff. Okay, so now we have all of our variables and we have all of our functions defined and we have our jet set up and we've done all of the heavy behind the scenes stuff that we have to do to set it up. So at this point, it should be pretty easy to just go ahead and write the code. So I'm going to stop this video and then continue in part 2.